Hello everyone. Today we will be covering the mechanism of the free radical substitution reaction. Now the mechanism is divided into three steps. We have initiation, propagation and termination. Okay. Now let's go over all of them one by one. Now basically what initiation contains is that the diatomic chlorine basically breaks the bond between them breaks by UV light homolytically. One electron from the bond goes to each of the chlorines and that produces these two chlorine radicals. This is the only initiation step that you need to know. Then let's move on to propagation. Now what happens in propagation is that the methane reacts with one of the chlorine radicals and that produces this other radical which is called the methyl radical, and this happens because one hydrogen is lost from methane. Okay, now methyl radical and hydrogen chloride is formed in this first step of propagation. Now in the second step of propagation, the methyl radical reacts with the chlorine gas to produce this halogenoalkane and chlorine radical. This halogenoalkane is called chloromethane. Okay, and this was what we wanted. This was our initial product that we required, okay, in the overall reaction. Now moving on to the last step of the reaction mechanism, termination. Now what termination has is that all the radicals that were produced in the initiation and propagation steps, meaning the chlorine radicals and the methyl radicals, they will react with each other in different ways to produce new products and in different proportions. Okay, now what exactly these products are, let's see. So the first way that they would react is that two chlorine radicals would react to form chlorine gas. Then the next way would be that a methyl radical reacts with a chlorine radical to produce chloroethane, which is our desired product. This is what we want, right? This is what we want. Now, the third product that can be formed is from two methyl radicals reacting with each other, which would produce this alkane, which is ethane, right? So this would be in trace amounts, it would not be in major proportion, so it would be in a very minimal amount, but it is still produced. Okay, so that is something to notice. This is the entire reaction mechanism of free radical substitution for methane. Okay, now what if this keeps on happening? What if we have excess chlorine that is being reacted with the methane? Then this is what it would look like. Okay, first the methane would react with the chlorine to produce chloroethane and hydrogen chloride. Then the chloroethane would react with the chlorine furthermore to produce dichloromethane. Why? Because what will happen is that another hydrogen will be replaced by the chlorine and that will produce CH2Cl2 and hydrogen chloride, and this method goes on. Then dichloromethane would react with chlorine furthermore and another hydrogen would be replaced and that will produce trichloromethane, and this is given a special name. Trichloromethane is more commonly known as chloroform. Okay, then chloroform can go more and react with chlorine to produce CCl4, which is tetrachloromethane. Okay, and this is also called carbon tetrachloride. So in this product we can see that all the hydrogens have been substituted by the chlorine and therefore there can be no further substitution, and this is where the reaction stops. So this is what happens if the chlorine gas is in excess. Okay, now moving on, what if we want to basically react with other halogens and not chlorine? Well, frankly speaking, it doesn't matter because the reaction would be the same. It's just a halogen replacing hydrogen. Okay, so this is what it would look like. The methane would react with fluorine, and one of the hydrogens of the methane would be replaced and it would produce CH3F, which is fluoromethane. Okay, and it would produce hydrogen fluoride. Similarly, as we did before, methane reacts with Cl2 to produce CH3Cl, which is chloromethane. Then methane can react with bromine to produce bromomethane and hydrogen bromide. Okay, and similarly, lastly, methane can react with iodine to produce iodomethane. So this is a similar pattern throughout the halogens reactions with alkanes. Okay, now we did all these examples using only the first alkane of the series, which is methane, right? What if we use another alkane? What if we use ethane? Let's try that out, shall we? Now with ethane, then this is what it would look like, right? With ethane, we have ethane over here, we have chlorine. One of the hydrogens of the ethane will be replaced by the chlorine, and that will produce CH3CH2Cl and HCl. Okay, and this would be chloroethane. Okay, now again, if we are to do the mechanism of this overall reaction, then it will be the same. Okay, now the initiation step would be the chlorine breaking into two chlorine radicals by UV light. Okay, that's as simple as it is. Then moving on to the propagation step. Now the propagation step would be similar to as what we did. Okay, first, the ethane would react with the chlorine radical to produce this radical, and this radical is produced because a hydrogen is lost from the ethane. Okay, and this radical is called the ethyl radical, and it would also produce hydrogen chloride. Then this ethyl radical furthermore goes and reacts with chlorine, which then produces this halogenoalkane, which is called chloroethane, and it also produces the chlorine radical. Okay, now what would the termination steps have? Again, termination is basically just whatever radicals were produced in the initiation and propagation steps, they will react with each other in different ways. So first, the two chlorines would react with each other to produce chlorine. Then basically these two chlorine radical will produce chlorine. Then the ethyl radical can react with the chlorine to produce chloroethane, which is the desired product, and that is what we have produced above in the propagation steps. Then lastly, the two ethane radicals, the two ethyl radicals can react with each other to produce this alkane, which is basically butane, and this will be in trace amounts. It will not be in a large amount, it will be in very minimal amount. Okay, and this is butane in minimal amount. And this is basically the entire process of free radical substitution. So no matter what alkane you have, the reaction mechanism remains the same. Okay, and that is it for today, and the chapter of alkanes is finished. Thank you.